Okay, so what if I told you that pretty much everything you learned in school about where oil comes from might be wrong, or at least not the whole story? Today we're diving into this really fascinating paper with just an epic title, Blood of the Titan. And it's all about challenging one of the most basic assumptions of our modern world, where our oil actually comes from. You know the story. We've heard it since we were kids. Oil is a fossil fuel. Simple as that. It's the juiced up, compressed remains of ancient life, dinosaurs, plants, all that plankton, that died millions and millions of years ago. But the paper we're looking at today, it throws a huge wrench in that simple story. It asks that exact question. What if that's not the whole story? It suggests that the version we all know and accept might be missing a massive piece of the puzzle. And, that piece could totally change how we think about energy and even about our planet itself. All right, so let's just quickly run through the official story, the one that's basically shaped global politics and economics for over a century. It's pretty straightforward, right? A three-step process. Step 1, ancient life dies, sinks to the bottom. Step 2, it gets buried under tons and tons of sediment. And step 3, over millions of years, you add a whole lot of heat and pressure, and poof, you get hydrocarbons. Simple, logical, makes perfect sense. This is the biogenic theory of how petroleum is formed. And this is the really critical part. If oil comes from a finite amount of ancient life, well, then oil itself has to be finite, right? It's a resource that we are without a doubt going to run out of. This whole idea of scarcity, it's the foundation of modern energy policy, the whole thing. Okay, but now, let's take a trip. We're going to leave Earth for a second, because the first big challenge to this whole story comes from a place billions of kilometers away, a place that gives us, the perfect natural experiment. Check this out. This is Titan, Saturn's biggest moon. Its surface has these huge lakes and rivers, but they're not filled with water. Nope, they're filled with liquid methane and ethane, hydrocarbons. And here's the kicker. There has never, ever been any life on Titan. No dinosaurs, no plankton, nothing. So what does this mean? Well, this is the crucial point. Titan proves, with zero doubt, that the universe can cook up massive amounts of hydrocarbons without any biology involved at all. Now, the paper is quick to point out this doesn't prove that oil on Earth is made the same way. But what it does do is it completely falsifies the idea that you have to have fossils to get hydrocarbons. That biological link, it's not a necessity. So with that fundamental idea now in question, the paper brings in an alternative, the abiotic theory. What if oil isn't just a product of the surface, but it's also a product of the deep Earth itself? The idea here is that really simple elements, carbon and hydrogen, which are super abundant deep inside our planet, are being cooked under the insane heat and pressure of the Earth's mantle. This process forms hydrocarbons that then slowly make their way up towards the surface. It could be like a primordial source for oil that's always been there. And let's just get this term straight. Abiotic synthesis. It's just chemistry. It has nothing to do with biology. It's about creating these complex organic molecules from simple, non-living stuff, using the planet's own internal heat engine. Okay, so the theory sounds plausible. We've seen it happen in labs, we've seen it on other worlds, but is there any proof that it's happening right here on Earth? Well, the paper points to a really, really curious case study. Meet Eugene Island Block 330. This was a huge oil field in the Gulf of Mexico. It hit its peak production, and everyone thought it was pretty much tapped out. But then, something really weird started happening. The reserves, they started to go back up. The field was refilling itself, which goes against everything we thought we knew. See, the standard model says an oil reservoir is like a sealed-off Tupperware container. Once it's empty for good. But what happened at Eugene Island suggests it might be an open system. It's possibly connected to a deep geological fault that's acting like a pipeline, just feeding new, younger hydrocarbons up from way, way down below. So let's just recap how the argument builds. The paper lays it out really clearly. First claim, hydrocarbons can form without biology. Evidence, Saturn's moon Titan. Confidence level, established, totally proven. Second claim, complex hydrocarbons are stable at mantle pressures. Evidence, lab experiments, and theory. Confidence, supported. And third, some reservoirs can actually replenish from the deep. Evidence, the Eugene Island case study. Confidence, supported, at least based on that case. Okay, But now for the big one, the major objection. If this abiotic oil theory has any merit, then why does basically all crude oil contain biomarkers, these little chemical fingerprints of once living things? I mean, this has always been seen as the smoking gun for the fossil fuel theory. Well, the paper has a really fascinating answer for that. It suggests that the deep Earth is a deep, hot biosphere, just teeming with microbes that literally eat hydrocarbons for breakfast. So as this primordial, abiotic oil migrates up from the mantle, it passes through these biological zones. It gets munched on and changed by all this life. So the biomarkers, they aren't proof of where the oil came from, they're just an overprint it picked up on its journey to the surface. So what are we supposed to make of all this? The paper's goal isn't really to prove that all oil is abiotic. It's more about arguing that this whole debate, it's not nearly as settled as we've been led to believe. So you've got two camps, right? On one side, the fossil fuel theory, a finite supply from ancient surface life with biomarkers as the proof. On the other side, you've got the abiotic theory, a potentially continuous supply from deep mantle carbon, where biomarkers are just a contamination, an overprint. I mean, these are two totally different ways of looking at our planet's geology. And this really brings us to the central message of the whole paper, which is summed up perfectly in this quote. It's not about fossil versus abiotic. It's not a simple right or wrong. The real scientific question is, what's the relative contribution of each? How much of our oil comes from one process and how much from the other? Maybe both are happening at the same time. So the big takeaway here is that the fossil fuel story became the accepted truth before we really had the technology to explore the deep Earth or, check out other planets. The paper is basically arguing that it's time to use our modern scientific tools and treat the origin of petroleum not as a settled fact, but as a genuinely open scientific question that really deserves a hard look. And that leaves us with one final, kind of mind-bending thought. If hydrocarbons aren't just buried sunshine, but are an active, ongoing part of the Earth's deep geology, it's blood, like the title says, then what other jobs are they doing down there? Are they lubricating tectonic plates? Are they buffering stress along fault lines? It completely shifts the perspective from thinking of oil as just a resource to seeing it as a functional part of a living planet. And that is a question worth thinking about.